This is the makeup video for video conference number 4, where we are going to be talking about array lists and comparable out of chapter 10. So what we're going to do is we're going to deal with an array list of presidents. So I'm going to just copy and paste in a couple of strings that I've got prepared. You can create whatever strings you want. I created presidents. You could do something different. Why not? I created two versions, one with first and last name, second with first name separated by last name. There is some very simple code. You can use the strings.split method to get the second form out of the first, but just for simplicity, I decided to do this. So we're going to start with that list of names. We're going to do this in 3 or 4 parts. So for part 1, we're just going to use ArrayList to, we're just going to say build an array list. Strings. Okay, so we're going to use the first of all, just get used to the array list terminology. So it's going to be array list, and then it's parameterized. So we need to tell it what kind of object is going to be stored in an array list string. So this is the first time in the class you've had to deal with parameterized objects, but you're going to be dealing with that for the rest of the class. So pay close attention to how this works. So ArrayList is a class that is provided by the Java collections, and it's a class that deals with other classes. So again, this is something new. Having an array of strings, you understand what that means. Well, what if you wanted an array of objects? Well, that's what you're going to use an array list for. So in this case, we're going to start with the very simplest type of object, one that's already provided for you, string. And this whole thing right here, this is a data type. So it's like an int, a float, a double. You've learned about string. You've also learned about your own classes, like if it was an animal class. This is the equivalent of saying animal. So I want you to treat it as such, okay? That is just the data type. What comes after the data type? It's always the variable name, okay? So that is going to be I'll just call it pres for presidents, okay? A little bit shorter. And then just like when you create an array, or you have to create an object for it. So you're going to create it by calling new. And then just like you would for an array, you're going to give it the data type, which is, just like I said, it's the exact same thing on this left-hand side that's before this variable. Okay, so it's got to be that full thing. And then we're just going to put open parens. Now, normally if it was an array, we would tell it how many items. But we are not going to tell it how many items because an array list is not a fixed size data structure. It's variable. So this creates an empty array list. So there's nothing in that array list yet. Not a single thing. Now all we've got to do is add these strings. So how can you do that? So you've got to walk through all of those strings. There's a couple different options, right? You could do a for loop. You could do a for each loop. What's the difference? A for each loop doesn't give us the index for the items. In this case, we're not going to need those indices. So I'm going to go ahead and do the for each loop. So it'll be for string s. S is fine because it's a very short-lived variable. And we're going to use the names. So what this is going to do is you have string s go through each of these 4 strings. And then we're just going to add them. So the name of the variable is pres dot, and then you can see all the different options. We're going to just add, and then the string will be our names index, or sorry, just s, because sorry, I did the for each loop. So we don't have to actually even index into the string, the array of strings. We've already got it. So it's just going to be adding that, and then let's just print it out. So we're going to run that. And why don't I drop this down here so we can get a better look at it. So there we've got the 4 presidents. Very simple. That's phase 1. Now let's do part 2. This will be build an array list of president objects. So as you might suspect, first thing we're going to do is going to create a class for presidents. So it's going to be, we're not going to use public, but it'll be class president. And then for the private members, it's just going to be first name and last name. And then I'm going to skip on the video of this class creation. I'll be right back. I'm not even going to show you how to do the class creation because you already know that right by now, right? So we're just going to skip that, and we've created our class president. Now what we're going to do is we're going to build that an array list of president objects. So it's very similar as before. We have to say array list, but now the parameterized data type is president. And then we will call this one, what shall I call it? Presidents, longer, equals new array list of president. Now, I should say that it is technically allowable to just have open and close here on the current version of Java. It wasn't prior to that, but I don't let students do that because I want to make sure you understand exactly what's going on here. So we're going to create that new list here, and now what we're going to do is just go through and build up this list. You may have realized by now that because the president has first name and last name fields, and you'll understand later why it does, I had this second list here of strings, and that causes a little problem because if you're trying to do the for each loop, you're not going to be able to get, you're just going to get one string each time, whether it be the first or the last name, and that's not going to work. So we can no longer use the for each loop. That's a good example of sometimes you can't use it. So we're going to go int index equals 0, and we'll do the index is less than the names first last dot length. So we are going to have a first name followed by a last name here. So actually the index we're going to actually increment by 2. And we're just going to do a presidents.add. And then the president, we actually have to create the president here. You can't just call the constructor here. You actually have to create the new item. In fact, just to be clear, let's go ahead and do that as a separate step. So I'll say president p equals new president, and then we need a first name and a last name. So that's going to be the names fl of index and the names fl of index plus 1. That's going to create the president, and then we're going to add it. And then we're going to do assists out of the presidents. Let's run that. Okay, it looks a little bit different because of my toString, but you can see it's once again George Washington, Abraham Lincoln, blah, blah, blah. Great. In fact, here, I'm going to quickly change my toString. Hold on a second. I just updated the toString so that it'll have this last comma first format instead. I think that'll be better. So that concludes part 2. We've now built an array list of president objects. Now we're going to go to part 3. We're going to actually insert the presidents in sorted order. Ooh, this is pretty exciting. Now this is not in the book, but it's something that'll prepare you for future chapters, and I'm going to lead you through it, so don't be too confused about what's going to happen here. So let's just talk about how do you insert something in sorted order. The simplest way to do this is we're going to always be in sorted order. This is the order the names come in. So imagine we first put George Washington into the list. Second name comes along, Abraham Lincoln. Okay, so notice I put the last name first because, of course, that's the most important thing. So we're going to check whether the last name is less than the last name here that's in the list already. If it is, then we'll just go insert it right there. Okay, then we'll have a list that says Abraham Lincoln and George Washington. The next person to come through will be Thomas Jefferson. Okay, so it's going to check first Abraham Lincoln. That'll be the first one. And then it'll say, nope, bigger than Abraham Lincoln. So then it'll check George Washington. And it'll say, oh, we're bigger than Abraham Lincoln and smaller than George Washington. So it'll insert it in the right place. So in order to do that, we actually have to be able to compare presidents. And to do that, we are going to have to add compareTo. So let's now finally go down and take a look at the class and show you how to implement compareTo. compareTo will allow us to compare two objects. So in my class, the first thing I'm going to do is I'm going to add the words implements. You've already seen implements once. Now the interface that we're going to implement is comparable. And immediately it's going to complain. What's it going to complain? We have to implement, let's get that. Okay. This president must implement the inherited abstract method comparable.compareTo object. That is what we have to do. And it also says it has to be parameterized, which is different. That's a new thing for you as well. So what that means is two things. One, we have to parameterize comparable to use president. You might wonder, why didn't it just assume it was president? Well, you'll see later when we get to other classes, you can actually have multiple parameterizations. So it's not always obvious what it's going to be. And let's just double check. This should have fixed the first error. Yes, now we're just down to implementing compareTo. So let's go to the end here and it'll implement compareTo. So compareTo returns -1, or actually I should say a negative number, 0, or a positive number. So if it returns any sort of negative number, the result is less than. 0 means it's equal. Positive number means it's greater than. And which way are we talking about? The return is relative this compared to passed in object. So let's make this concrete. So it's public int compareTo. Then it's going to take a president. So if the president that is represented by this is George Washington, when you call George Washington .compareTo Thomas Jefferson, Washington is greater than Jefferson in the alphabet, so it should return +1. And let's think about how are we going to compare? Well, we got to compare the last name and we got to compare the first name, right? And luckily we have those fields, and we have to compare it in order. We want to compare if last name different, return that comparison. Else, return comparison of first name. So we want to return the comparison of the first name. So how do we tell if the two last names are different? Well, we can do a .equals ignore case, right? And that'll tell us whether it's equal or not. But that actually doesn't tell us whether it's less than or greater than. But you know what? We can actually call compareTo on the string class. It's already been implemented for you. So all we have to do is I'm actually going to grab the comparison between the first and the last names that's already provided to us by the string class. So I'm going to say first comp is equal to this dot first name dot compareTo of p dot get first name, and then int last comp was this dot last name, and actually let's let's go ahead and change that to be get. This dot get first name, and this will be this dot get last name dot compare to of p dot get last name. So this will tell us whether the first name is less than or greater than and last name is greater than. So now we can actually implement the pseudocode I wrote here very easily. So if last comp doesn't equal 0, return last comp. Else, return first comp. And that's it. Got an extra one there. That should now compare by comparing the last name first and then the first name. Now, what do you always got to do? We can go ahead and write this code to insert the precedence order, not knowing whether compareTo works, but that would be a very silly thing to do, because then we're going to be debugging our code plus compareTo. So the first thing let's do is let's test this out. So I think this line actually belongs here. And part 3. So let's just compare two things, okay? So let's sys out, and let's sys out. We've got an array of precedents. Let's just randomly pick whether 0 and 1 are less than or equal to each other. Okay, so I'll say sys out of precedents.get of 0. So that's actually going to print out George Washington because it's got a toString. Then let's say I can just directly call compare precedents.get 0.compareTo of precedents get 1. That's going to print in the middle of the string. It'll say George Washington -1, 0, or 1. Then I will put precedents get 1. And as soon as I finish writing this, really what I should have done is had some variables for precedents get 0 and precedents get 1. So, and I think I've got a closing bracket that's missing. And let's see, is there an error or is it just... Okay, precedent and int. We've got a precedent's got... Let's try forcing this to an int plus... That's not going to work either. Oh, it did. Huh, interesting. It did. Let's try running it. Okay, George Washington, 11. So that's a number greater than 0. Abraham Lincoln. Now, why did it say 11? I thought it was going to return -1, 0, or 1. Okay, that's because I remember I said that that compareTo returns positive, 0, or negative. It doesn't say that it's going to be 1, 0, -1. So what I really want to do is return, well, we could do it two ways. We could actually just use this number as is. Or we can actually return 1, 0, or -1. I could put a little extra code in here, but I'm not going to do that. You're just going to have to believe me for now that we could. So let's put actually a space around that. Makes it a little bit great. Now, do you believe that that's enough testing? I don't think so. Why not? Because we only tested one way, right? So let's make a little loop here. we're going to look through all three comparisons. So index equals 0, index is less than presidents dot size index plus plus. Now I'm actually going to write the code that I should have, which is president current equals presidents.get 0, president next equals presidents.get, oh, not 0, it's that index plus 1. Okay, so we're going to get these two presidents, and then we're going to compare them. So I can replace presidents.get 0 with current, and then presidents.get 1 with next. See how much easier this code looks like making that replacement? That was well worth it. So we're going to do that 3 times. Let's run that. So we've got, so George Washington is bigger than Abraham Lincoln. Yes. Lincoln is greater than Jefferson. Yes. Jefferson is less than Roosevelt. Yes. Perfect. So that's exactly, oh, you know what? This still isn't good because I don't have testing 0. So let's put that in there. Oh, what was that red? Oh, we are actually going out of bounds line 34, even though it finished and then it crashed. Okay, I think I know what the problem there is too. First of all, let's see what happened. So yes, it did get 0. All right, so what is the problem here? We're going out of bounds in line 34 because we're going and looking at index plus 1. So the problem is that we need to look at size minus 1 because we're looking at this one compared to this one compared to this one compared to this one, and then it's checking this one compared to, whoop, going off the end. So once I stop looking one element too early, now it doesn't crash on us. Okay, but we're getting a little bit distracted because what we were trying to do is to actually insert these. So we've now verified that these things are working correctly. We're now actually going to do the insert. So the insert, let me give you the pseudocode for the insert. So you aren't expected to know this, so I'm just going to give it to you. The algorithm for inserting in sorted order is you're going to store the first one, then you're going to insert the following presidents wherever they belong in that sorted list. To do that, you build the president for the next president, then you look through the sorted presidents. If the new president that you just built is less than the current president, you insert it here. If you keep on doing that, then every president will be inserted in the correct order. So let's go ahead and do that. So the storing the first one is pretty simple. We're just going to, we got to create a new list first of all. So let's do that. ArrayList of present. And then it'll be pres sorted equals new ArrayList of president. And we're going to store the first one. And then we've got to create the new president. I'm just going to do it inline here. And remember, we're getting this here. And we can actually just take this basically and copy and paste. So we're going to start index 0 and then index 1. That's going to add the first president. Then we're going to insert the rest where they belong. So we need a for loop looking through these. Now we're not going to look at the first one. We are rather going to look at the second one. But remember that we're talking about the first and last names, so that's actually index 2. And then it's names fl.length. And remember, because we're looking at first and last names, we have to add 2. And let's put a close brace down here. Now we got to build a president. So president P equals new president. Oh, let's just copy and paste. Except we're going to have to change the 0 and 1 to be index and index plus 1. Now we're going to look through the sorted precedents. We have to have a second. Oh, we're going to have a second list loop here. And I'm going to use a more intelligent variable for this inner loop because we don't want to get confused as to whether we're looking at the names. In fact, you know what? That wasn't the most intelligent thing either. Let's rename that to be index name. See, that makes a lot more sense. Okay, so the current president equals 0. Current president is less than pres sorted dot size cur pres plus plus. Now, if the new president is less than the current president, insert here and stop looking. So we're going to do that code if president P dot compareTo, and what's the current president? Well, that's going to be pres sorted dot get cur pres. Is that closed? Fully closed? Let me check. 1, 2. Okay, then we had to actually compare. If that's less than 0, so if this one is less than the current one, now we're going to insert it. Pres sorted dot add cur pres, and then we've got to get the new president. Okay, that's going to add our president. I think we left a closing brace off there. So we're going to add the new president. Now it's very important that you actually break here, because if you don't, it's going to actually keep on looking through that loop, and that's not what we want to do. I think I'm missing a close brace for the for loop, and then that's looking better. We've got index name. Oh yeah, int. And then, okay, the rest of it's good. Okay. So now let's review what we got. So we're looking through each of the names here to build a president. So we built it. Then we're going to look through the existing presidents. So we're looking now through pres sorted. We compare the president we just built to each item in the sorted list. If it's less than that one, we're going to go ahead and insert it at that current position with the new president. Oh, you know what? Actually, I don't need to do this, right? Because I already built it. We just have to insert P. And, oh yeah, just too many close braces. There. All right. Now, what we're going to do is we're going to actually set a breakpoint on here and actually step through this now, because this is getting to be tricky code. All right, so we have now built, let's go take a look at our variables, and let's see if I can, there we go. So let's take a look at where index name, let's step into this. Okay, so index name is 2. And what we're going to do is we're going to build a new president P. Why isn't it giving me values? Let's just shrink that over and then move that back. Okay, so that's Abraham Lincoln. That's good. We wanted, so George Washington is already in the list, so let's take a look at pres sorted. We're going to expand the element data, expand president. See George Washington there? Okay, so that's good. So we got George Washington. And we're going to compare P, which is Abraham Lincoln, to George Washington. It is less than 0. That's correct. So now we're going to insert it right here. So pres sorted, you should watch here. It should insert it right before George Washington. See Abraham Lincoln, George Washington. And it's going to break. And it goes to the next one, builds the next president. And let's take a look. What's P now? P is Thomas Jefferson. So where is it going to put Jefferson? It should look past Lincoln, but stop at Washington. So we're going to do the first comparison, and it's less than Lincoln. Oh, wait, right, sorry, Jefferson less than Lincoln. So it's going to insert it right here. So now we've got Jefferson, Lincoln, and Washington. Okay, let's go to the next one. Now we've got Roosevelt, I believe. So Roosevelt is going to go after Jefferson, after Lincoln, but before Washington. So the first comparison doesn't work, so we go to the next one. Second comparison is going to compare it to Lincoln. It's greater than Lincoln. It's going to go to Washington. Here it inserts it. So let's take a look. After Lincoln, we get Roosevelt. And finally, Washington's down at the end. So let's go ahead and just continue on through the program and let's look at our output. Oh, I never actually printed the output. Let's do that. Let's just run that code. And now it's Jefferson, Lincoln, Roosevelt, and Washington. I've got 2 Roosevelts in there. So let's go ahead and just, no, that's fine. What the heck? So that all worked. Now, there's one last step, and I'm just going to give this to you, but it shows you the power of what's going on. How would you like to do that all for free? Use polymorphism. So it just so happens that Java anticipated this need to sort collections. So you can do this, collections, and again, you don't need to know how to do this. The book will tell you later, but I'm just going to show you now. Collections.sort, and then we're just going to give it not pres sorted, but presidents. Remember, that's the unsorted list. Run that. Boom. It did it for free. None of that code we just wrote was necessary. That is the beauty of polymorphism, because Java has a sort routine that knows how to deal with an array list of any type of object, an object that's never seen before. So that's the real power of polymorphism. And that is the end of the video conference.